In this video for section 6.1, we're going to talk about how to use Gaussian elimination to solve a linear system of three equations with three variables. It's pretty similar to solving a system with two equations, there are just more steps. So first you're going to write the augmented matrix, and then you're going to use matrix row operations to put the matrix into row echelon form. The order is that first you get the 1 in the upper left hand corner, and then you use the 1 to get zeros below it. Then you get the 1 in the second row, second column, and then use the 1 to get 0 below it. And lastly, you get the 1 in the third row, third column. Once you have the matrix into row echelon form, you write it back into a system of equations and use substitution to solve. So we're going to look at example 3 from the textbook. My first step is writing the matrix. And the first thing that I need to do to the matrix is get 1 in the upper left-hand corner. Now remember, the easiest way to do this, if you can, is to do it by switching the place of two rows. So if I have a 1 in the first column, then I can move that row up to the first row to get a 1 in the correct position. Now I have a couple of options with this problem because I have two 1s in the rows below the first row. So I could switch row 1 and row 2, or I could switch row 1 and row 3. I'm going to switch row 1 with row 2. But it doesn't matter, you should be able to get the correct answer regardless of what you do. So I'm going to put 1, 1, 2, and 19 into the top row, and 3, 1, 2, 31 into the second row, and my third row does not change. So what I need to do next is get zeros in the two positions below the 1. And in order to do that, I'm going to multiply row 1 by the opposite of whatever number is there and then add it to that number. So I would multiply row 1 by -3 and add that to row 2 in order to get rid of the 3 in row 2 and make that into a 0. So row 1 here is not changing. -3 times 1 is -3 plus 3 is 0. -3 times 1 is -3 plus 1 is -2. -3 times 2 is -6 plus 2 is -4. And -3 times 19 is -57 plus 31 is -26. And then my third row stays the same. And now I want to get this 1 in the bottom left-hand column into a 0. And the way that I would do that is multiply row 1 by -1, or just take the negative value of whatever is in row 1 and add it to row 3. So my first two rows are not changing. We're going to have -1 plus 1 is 0. -1 plus 3 is 2. -2 plus 2 is 0. And -19 plus 25 is +6. So now I'm finished with the first column. And my next task is to get a 1 in the second row, second column. Now, what I'm often going to want to do in order to get this is I'm usually going to want to do it by dividing. And especially if all three of these numbers can be divided by whatever number is in this second column position. In this case, it's -2, And both -4 and -26 can be divided by -2. So that's good. So I'm going to do R2, row 2, divided by -2 next. So my top row doesn't change. In the second row, I'm going to have 0, 1. -4 divided by -2 is 2. And -26 divided by -2 is 13. My third row does not change. Next, I'm going to get a 0 in the position below that 1. Now, the way that I'm going to do this is I'm going to work with row 2. I'm going to multiply this 1 here by -2, and then adding it to that 2 is going to turn it into a 0. Now, I don't want to work with row 1 here, because if I multiply row 1 by -2 and add that to row 3, that would give me -2 here where this 0 is that I already got. And so that would be undoing that. So I don't want to do that. I just want to work with row 2 because there's already a 0 there. And -2 times 0 is 0. 0 plus 0 is 0. So it won't change the zeros that I already have in the first column. So I'm going to do multiply row 2 by -2, because that gives me -2. -2 added to +2 is 0. So my first row isn't changing. And my second row isn't changing. But in the third row, I'm going to have -2 times 0 is 0 plus 0 is 0. -2 times 1 is -2 plus 2 is 0. -2 times 2 is -4 plus 0 is -4. And -2 times 13 is -26 plus 6, that's -20. So I only have one more thing that I need to do here, and that is to make this -4 into a 1. And again, I'm going to do that by dividing. -20 can also be divided by -4, so that's good. That means my numbers are going to come out to be whole numbers. So I'm dividing R3 by whatever number is in this position, so -4, in order to turn that into a 1. So my first row doesn't change. And my second row doesn't change. But this third row, well, 0 divided by -4 is 0. 0 divided by -4 is 0. -4 divided by -4 is 1. -20 divided by -4 is 5. So at this point, I've completed putting my matrix into row echelon form. So now I'm going to go back and write the equations. The top one is x plus y plus 2z equals 19. The second one is y plus 2z equals 13. And the last one is z equals 5. So I have the value for z, and I'm going to substitute to find the values for x and y. So plugging in 5 for z into the second equation gives me y plus 10 equals 13, so y equals 3, subtracting 10 from both sides. Now I plug both z and y into the top equation to solve for x. So x plus 3 plus 2 times 5 equals 19. That's x plus 13 equals 19, and so subtracting gives me a value of x equals 6. So my answer, my x coordinate is 6, my y coordinate is 3, and my z coordinate is 5. And just like earlier, for these problems with 3 variables in the answer, they're going to have the parentheses and the bracket for you, and you're just going to fill the 3 numbers into the boxes. So next, you should look at checkpoint problem number 3, Do this in your notes, check your answer, and then you can do the optional practice problem for this section.